The air handling unit, which uses heat exchangers that run on negative temperature, need defrost. But if you will alternate two coils which supplies air for the same duct, you have to make sure the dampers are properly isolated and they can hold. Now you will see here we alternate two heat exchangers, so one goes on defrost while the other one running on minus 15 degrees. Now when the coil which goes on defrost will reach 60 degrees and you will melt the ice, the liquid, the water, will convert in steam and it will leak onto the cold chamber, and then I will have an average temperature which is not good. And this is the measurements I did, and as you will see here, the relative humidity go up to 90 and then go down to 50, while the temperature goes up to 4 and then goes down to 1, which is not a good news because it's February and outside it's about 5 degrees Celsius. So when the summer comes, then it will be a serious problem. So what I'm rushing to do, I have to do some modification to this system to bring it up to standards. Now, one of the most important things to do, it is to try to increase the temperature of the heat exchanger and also to increase its area. Now what you will see here, I made some measurements I did inside the room in different locations, and I will get through them very fast so it won't be boring. You will see every single corner have a different humidity and different temperature, which clearly show that one sensor will never show you the truth. So how can I change this? How can I have a smoother reading? How can I stop this humidity to go constantly up and down and the temperature to vary so much? I designed an inline heat exchanger meant to provide cooling capacity to a room which needed the most. This is a closed loop which is controlled by a pump and two actuators. I measured this to make sure I have the smaller possible resistance to the airflow, so I will not increase the power of the fan. And this is the main view of the system. I have two closed loop, one go to the main heat exchanger and one to the heat exchanger I designed. Now I will use enough glycol just to maintain these two closed loop at 0 degrees Celsius, so I will not use the defrost. That will give me a benefit of using both heat exchanger into the air handling units in the same time. So then it will not be any steam to mix with the cold air and to affect the relative humidity and the temperature. Also, the secondary heat exchanger I built in line with the duct which supplies power to room 323 will drop the temperature more, and that will overcome the problem. I'm sucking from outside 0.9 meter cubes per second, which means I'm about almost 3,000 cubic meters per hour. And when the summer comes, the air will be 29 degrees sometime with 80 degrees relative humidity. Imagine the amount of work the fresh air conditioner have to do. So what you see here on the left hand side, it is the old reading. What you see on the right hand side, it is what I want to achieve. The top reading will be the air after the primary heat exchangers, and the low one, it's when the air will pass the secondary heat exchanger I put in line for room 323, and the relative humidity will be much smoother. That's what I'm trying to achieve, a smoother reading. And I use a thermal camera to find out the hottest spots into the room 323. As you will see around the doors source of heat, uninsulated pipes which are very hot. And this is from outside to see how much cold air I'm losing through the door constantly. And then you'll see from inside out how warm is the door and the red spot where is the sensor located. So if you look to all this reading I did, you will just realize that this system is quite imperfect and it needs a lot of improvement to run the way it's supposed to run.